see.
Hey, am I live now?
Yes, now you are.
Oh my god, dude. YouTube, you gotta be kidding me.
No worries. Sorry,
Hey
bro.
everyone. Okay, I
Okay,
thought I was
well,
streaming for the last 30 minutes and
okay. Enjoy your stream. Maybe do a tweet to say you had some trouble starting it.
yeah, thanks guys. All right, hey everyone. So yeah, I thought I was streaming for the last 30 minutes and um yep, I thought yeah. Apparently YouTube you have to click go live in addition to streaming from, your OBS or whatever. Oh boy. I guess we got to restart. uh, okay. Let's restart. Um, um, okay. All right. It's okay. Damn. Sorry, everyone. Yeah. This is the first stream, on YouTube. So yeah. Forgive the technical difficulties. All right. So starting again. So okay, um, we're gonna build just a dead simple swap, like the most basic possible example. Um, we're just gonna start from scratch. Oops. All right. Um, okay. So if you want to follow along, check out the link in the banner, 0xbrock.github.io/livestreams. Um, I've got like a content outline here that sort of covers what we're gonna do, um, and has links for the stuff that you need. Okay. So, okay, let's start off by running SUAVE. So go here, GitHub, Flashbots, SUAVE, clone that baby. Once you've cloned it here, make SUAVE if you want to run it locally, or because I've already done this, I gotta turn it off and turn it back on again. So if you want to run the stack in Docker Compose, just run make devnet up. It will build everything in Docker, and it will run SUAVE, which is like your core, SUAVE MAVM, and then it'll run SUAVE execution geth, which is a modified Ethereum L1 like geth node, and it just has some custom endpoints for SUAVE to communicate with the MEVM. Yeah, so L1 and L2 can communicate. It doesn't matter a whole lot if you're just starting out. Like, you don't have to get into that. But yeah, just so you're aware, that's what we're spinning up here. So yeah, here's MEVM, and then there's SUAVE enabled chain. That's SUAVE Ethereum, or SUAVE execution geth is the other thing we're running. All right, so don't really need to worry about that. But okay, so when you're running SUAVE geth, you should see something like that if you're running it with Docker. And I'm just gonna stick with that for the demo. Okay, and then in this live streams, so if you go to GitHub, /0xproc/live streams. So I'm going to push all the code here, and then I'll just put it in a SUAPP directory here. So you'll be able to pull this code as I write it, and run it yourself. Okay, so let's start. Let's build the SUAPP. So a SUAPP starts with some smart contracts. So we shouldn't have this here yet. Okay. Oh man, I did this on the main branch. Okay. Sorry. So yeah, this all shouldn't be here, but you would run forge init, and then you would get this. If we open that up in editor, yeah, we just have the basic forge project. And what we'll do is we'll just take this counter project and turn it into a SUAPP. So start doing that. We need to import SUAVE std. So just forge install Flashbots /SUAVE std. And we've already installed it here, so that's going to give me an error. But let's just make sure we have the most up-to-date dependencies. And now, yeah, this looks good. So now we can use SUAVE in our smart contract. So we'll just call import SUAVE from SUAVE std /SUAVElib /SUAVE.sol. Okay. Autocomplete is iffy here. The plugin doesn't do too well, but here it is. So this is like everything that we have access to. Yeah, check it out if you want to get a sense for what we can do with SUAVE. But there's some pretty cool stuff in here. But alright, what we're going to be using is the confidential inputs. So in this function set number, you see it takes this argument in the traditional call data, and we want this argument to be confidential. So like call data is public to the mempool. Like if you see pending transactions, you'll see this. You'll be able to read it before the transaction is executed. And that's what we want to make confidential in this example. So we'll delete that parameter from there, and we'll read it from confidential inputs. So to do that, first make a bytes memory something, and we need to call suave.confidential inputs. Oh, did I hit the mic? Is it back on now? Dude, streaming is hard. Hold on.
Alright. Yes.
Is it back? Oh my god. Sorry, y'all. Once again, streaming is hard. I have a mic mute hotkey that I must have accidentally pressed. Okay. So let me make sure I've explained everything. What we were doing is replacing this call data parameter with a confidential inputs parameter. And so when you're calling a function with a confidential request, everything that happens in that function has to be an off-chain operation. It can't modify any on-chain state. So yeah, we have to comment out this state assignment here and move it somewhere else. And we'll set that up in just a second. Real quick, we can delete that. We're not using it. In this function, we want to make sure that we're calling this function from a confidential compute request, because we're going to be doing off-chain operations. We want to make sure this is being called, via a confidential request. So the way we do that is we can just make an assertion or require. We'll do require SUAVE dot is confidential. And so that's just like a helper method that makes sure that this is being called from a CCR, confidential compute request. And for convenience, we can even move that to a modifier. This is what I usually do. So then you can just say confidential here. And now, if you call this function and you don't call it from a CCR, it'll throw an error. It'll revert. All right, so now how do we set this number? We can't modify on-chain state here, so we have to do it somewhere else. And the place we do that is in a callback. Oh, sorry, one sec. Let me, I should close the chat. I want to open up the chat again. Sweet. Okay, so we got to set this in a callback. And this is how SUAVE separates on-chain, off-chain operations. So we can just write a new function, like onset number. It's public. Confidential? Not confidential. We'll see why later. Onset number will actually take the number as a parameter here. And that's where we can set it. So number is being set here. And then to actually trigger this, the way we do this in SUAVE smart contracts, you have to ABI encode the call data in the return value of set number to call onset number. So let me just write this out and I'll explain it. Let's modify the return signature of this function. It returns bytes memory. And then we need to ABI encode. You can use with selector or with signature. With signature is convenient if you just know like onset number. You meant 256, and that's never going to change. But if it does change, which it often does when you're developing, you have to remember to adjust this magic string. And so for that reason, I prefer encode with selector, which lets you so you can actually just reference the selector from a function definition. So if we replace this with this dot onset number dot selector, kind of annoying that the VS Code Solidity plugin doesn't pick this up, but it's here. and that will just automatically target this function. So if you ever change the signature, then it won't, it won't break your code. This will still be a good reference. Okay, so then our arg is new number. All right. So now when we call this function with a CCR, it's going to take the confidential inputs that we gave it, decode them into a uint256, and then return the call data to call onset number, which will take care of the on-chain state updates that we want to do. Okay, onset number is also, events are state updates as well. So if you wanted to emit events, that's where you would do it. So we could make one, for example, number set, and emit it here. Emit number set new number. Cool. So now that's good to go. All right, so let's just build everything. Make sure it works. Okay, so the counter test is failing, which makes sense because now it's testing the wrong thing. I'm just gonna disable those for now. We'll come back to test in a minute. Okay. So the build was successful. So now we've got a SUAPP that we can deploy to SUAVE. Let me get the logs out of here. So yeah, just doing normal geth things. But yeah, we wanna deploy this to our local SUAVE DevNet node. So I like to use forge create for this. And we'll need a private key to send this transaction with. So I've got a PR here for the docs. It's not merged yet, but we'll just use this pre-funded account. So this is just like included with SUAVE DevNet. This private key has like 10 billion ether, so we can test with that and do whatever we want. But yeah, we'll forge create private key, and then we just need the path. So source contract, or yeah, source counter.sol, and the name counter. Okay, so that's deployed to this address. We can just save that. But we need something to call this. We need something to actually interact with this SUAPP. So there's a handful of clients that you can use. The one I'm going to be using here is in TypeScript because it lets you make web apps as well as server-side apps. So that's what we'll be doing here. But if you want to use a different programming language, there are a couple other options. There's SUAVE Alloy from this guy, Miha. So you can use that if you want Rust. I'll post this in the chat. And then there's some examples in Geth here as well. I'll post those. So yeah, if you want to use Rust or Go, check those out. But yeah, this one's TypeScript. Okay. So yeah, we could see from the SUAVE Geth logs that our contract creation worked. So okay, let's build some code to actually interact with the SUAPP. All right. SUAPP live stream. Okay, so if you go to the live streams repository, where is it? I already have it open, don't I? Yeah. This branch is live. Ignore this. Here it is, SUAPP live stream. So if you want the code to just run yourself, you can just get it here. And I'll just be pushing it to this branch. Okay, so we need a new project within this project to do some TypeScript stuff. So just make a directory. SUAPP. And let's just roll everything into one, and we'll make a web app, because that'll kind of show you everything that SUAVE can do. SUAVE is the library that we're using in TypeScript. But yeah, if you want to make a web app, I like Vita, I think is how it's pronounced. You can just run bun create Vita. If you give it directory, it won't double nest your project if you already made a directory. You run that, and I'm just going to choose React. Yeah, you can use any one of those, it doesn't matter. Then in here, I'll just install everything to start. And this should give us just like a starter web app. Yeah. So this is what we're going to be modifying, making a SUAPP out of. I need a new one. Alright, so we need to get SUAVE in this project, so I can just do bun add at Flashbots / SUAVE. Alright, now let's get out of the Solidity code into this. Here, source app tsx. This is where the magic happens. I'm gonna delete all this boilerplate stuff, but I like this little thing here. I'm gonna keep that. Don't need those. Man, thanks. Hold on, I'm gonna fix this. Okay, is it back now? Sorry, one sec. Hey, okay. Yeah, I definitely gotta move that hotkey. That sucks. Alright, thanks chat. Okay, so yeah, all I was doing here was setting up this state hook. This is just like a variable that persists across page renders in the web app. So we'll use this to hold the value that's represented in the smart contract. All right. Then we need use effect from React. Use effect is just something that runs when we load the page. We don't actually want that, but well, we could use that to test. All right, check that out. Yeah, the number's 42. So we'll use set the number when we read it from. We'll query the chain to get the actual value and use this function a bit later. But we need to set up a wallet and a provider to actually connect to SUAVE to do any of this stuff. So I need to import some SUAVE VM stuff here. Import get SUAVE provider, get SUAVE wallet, and we'll need the type transaction request SUAVE. Yeah, that should get us going. Okay, so then when the window loads, it's going to call use effect, and we need to look for the Ethereum provider. So like if you have MetaMask, which maybe this account doesn't. This is a fresh Chrome account, but we'll see. If you have MetaMask, window.ethereum will be populated in the app, so we just need to pick that up and see. We'll do that like this. So we need this async function. Gotta do some async stuff, and then we'll just call it. And then, okay, so if window in Ethereum, this is like the, oh, whoops, no, backwards. If Ethereum in window, there we go. This is just like the JavaScript way of checking to see if an object has a property, because it's possible that it's undefined, that Ethereum doesn't exist. So we need to make sure here before we try to reference it. But if it is, then we want to say, we want to get that. So window.ethereum. Ethereum, it's like an unknown type. I don't want to give it a type. Let's see if we can find something. We can just define its like core properties. It's got a request method. And it returns whatever. It doesn't like that I'm using any. But okay. So we've got window.ethereum. And this will give us, the MetaMask provider. But if you use the MetaMask provider, you're locked into whichever RPC that wallet's connected to. So for the SUAVE provider, so it's basically a SUAVE wallet is just a SUAVE provider with an account attached to it. A SUAVE provider we're just going to be using to read stuff from the chain. And for that, we can actually just connect directly to the node and not use window.ethereum. But we're going to set up the SUAVE wallet first since we're already doing it. So I'm going to put the wallet in a hook. And that's a SUAVE wallet. Make sure we're importing the types correctly. And SUAVE wallet wants a transport type, and our wallet is it's called a custom transport, this is just basically letting us know that it's using EIP 1193, which is how wallets take requests from web browsers. So like in MetaMask, well, you know, if you want a MetaMask wallet or whatever, you initialize this with a custom transport. Okay. So we can just do get SUAVE wallet, and then the params it wants are transport, and this isn't exactly the same as this. I mean, it's the same thing, but it's got a different way of doing it. You just need to call it a custom function. So that's there in Flashbots /SUAVE VM. And this is just a helper function to create this custom transport. All right, so we can, when creating the custom transport, we just pass it this ETH window.ethereum, and that should connect us to MetaMask. And then after that, we just need a JSON RPC account. So you see there's two optional parameters here, JSON RPC account and private key. So if you have a wallet where you have the private key in memory, then you can provide it here, and you won't have to use a custom transport. You can just use like an HTTP transport. But if you're using a custom transport, it's going to expect JSON RPC account, because it's basically sending a request with an unsigned transaction to the wallet, and then the wallet is responsible for taking that and signing it. And so the JSON RPC account is just going to be the address that you want to sign with in MetaMask, and then private key is if you have the private key. So we'll use JSON RPC account here, and we need MetaMask to give us the account to use. So we actually can't do that yet. We need to do first, we need to get the, we need to call the, request accounts method. I want Copilot to do it. I know it can. Yeah. Ah. Oh, whoops. Oh, it might be... I'm doing this wrong. Oh, whoops. I've got something... Oh. Oh, whoops. There it is. I think that's it. Something wrong here. One sec. I've got some reference code I can look up to get this right. There we go. Yeah, so TypeScript is kind of annoying in that it wants this Ethereum provider definition for window.ethereum. And it kind of complains if you don't have it, but we can just define it and then get rid of all this nonsense. And that'll make it a little easier for us to reason about what ETH is. Oh, I just like screwed up my brackets here. What did I do? Oh God. Oh. Almost. Okay. There we go. Okay, then we're just gonna move this up. Let's see if that worked. Oh. Alright. Oh yeah, and yeah, we're seeing here that we actually don't have window.ethereum because on this fresh profile, I haven't installed it. So let's install it. Where did it go? Extensions. Yeah, here's what the hotkeys for. Enter my password. Okay. Come on. Give me a wallet. Okay. Now I got MetaMask. Now this should work. And yeah, it's going to request my account. And there we go. So 89BF1. That's us. So let's hold on to that value. Say connected account is whatever this returns. We'll say it's the first account. So that connected account to account 0. And make sure it's greater than 0. And this should be array of strings or array of hex. A hex is another helper from SUAVE VM. It just makes sure that there's a 0x in front of the string. Nice and convenient. Unknown is not assignable, but we know what it is. We can force it using as. Yeah. So it counts as an array of hex strings. Looks good. Now we've got the connected account. Oops. Yeah, so now it's rendering. Cool. Can I move this? Yeah. That's better. Okay. So we're almost there. We need we got the account, now we need to set up the wallet, and we need to set up the provider to connect to SUAVE. So let's see, how should we do this? When we load it, we're going to check to see if Ethereum's available, and if it is, let's also do this. Let's say if connected account isn't defined, because we don't want to be calling this every single time we load the page. We only want to call it if we don't have a connected account. All right, and then also in here, if wallet is not defined, then we want to get the wallet set up. We just call get SUAVE wallet, and it accepts a transport, which we're using custom for this because we want to use the MetaMask provider. Yeah, and this is just custom ETH, right? And then the wallet, JSON RPC account, and that's going to be connected account. And need to make sure connected account exists. Make sure that we cast it to hex. It always will be, but TypeScript needs to be sure. And then we need to just put that in here so that we have access to it outside of this function. Cool. So now we're nearly there. We got a wallet hooked up. And now let's get a provider so that we can do some chain queries. Make a use state, SUAVE provider, and it takes a transport type generic parameter as well. And this is going to be, I want HTTP transport here, because I'm just going to hook it up to my local host to make it easy. And in this, yeah, we don't even have to do it like in this function. We just want to make sure it happens. So we can just say set SUAVE provider to get SUAVE provider, and this just takes a transport. So we'll make one with the HTTP function. So this is just like the custom function, but for HTTP. And we can give this our URL, localhost 8545. That's where SUAVE runs by default. And now SUAVE provider should be set. So now, anywhere else in the app we can say if SUAVE provider is set, like, let's check for the number when we load the page. How do we check for the number? We also need to import the AVI from the contracts that we built. So here in the SUAPP directory out, there's all our build artifacts, and we need to import that so that we know how to encode the function calls. So we can just import the JSON directly, which is a nice feature of TypeScript. Let's say import counter from. We need to be conscientious of the path here. So this is yeah, up to directories into the out directory into the counter.sol directory, and then counter.json. Okay. Now we should be able to use something like counter.abi. Yeah, see, there's all the stuff you need. If you wanted to deploy contracts from SUAVE VM, you could do it here with the bytecode. Yeah. So we just need the ABI, and we need a function to call that that number function. So this any public variable like this is also going to be represented as a getter function. So we can just call like number, and that will act like a function call and give us the number. So okay, let's write a new function to get the number. Async, because we gotta wait for the result, and SUAPP provider, just make sure, and just want to do SUAPP provider.call. Let's save that. Async call. So the arguments for this, let's see. It's like a transaction request. So we'll have two. All right, where do we save the counter address? Did we save it at all? There's our connected account. Yeah, when we created it, I'll just deploy it again here. So there's our contract address. We'll just hard code that for now. So then that's what we're going to send the call to, counter address. And then the data, this is how we'll encode the function call. Counter.abi. Does that work? Yeah, I didn't think so. That's looks like a geth thing. That's not how that works. Copilot wrong. No, VM has a function to do this, so we can call, just type encode function data. Autocomplete should find it. It's in SUAVE VM top level. Yeah, encode function data, which takes an ABI, which is that counter.abi, takes args. Don't know why it's auto-completing to arguments instead of args. But these are just the, like the function arguments. And in our case, we actually don't have any. We're calling it with an empty argument, so we could actually just omit that. And then function name, number. Yep. So yeah, that will call the number function. Using call, we'll just do a non-executing transaction, simulate it, and give us the result. Is there anything else we need with this request? To and data. We don't need gas, so I think that's probably fine. Let's try it out. We need to call this function somewhere. Get a number. Let's just try it out and see what happens. Oh, yeah, I can see why this isn't working now. We need to set these. These are like uh, yeah, dependencies for this use effect function. So this array down here, if you don't give it anything, this function only ever runs once. But what we're doing is we're actually going through like multiple steps where we initialize the page, we connect it, then we reinitialize the page and render, we got the account or whatever. And then we go through another iteration of this. And so if we don't call this multiple times, or we don't allow it to be called multiple times, which is what we're doing here with this empty brackets, then this will never, the SUAVE provider will never be initialized, or this won't ever be called, because it'll get initialized and then load won't run again. So we just need to specify these to trigger reloads for different variables. So if we set wallet, we want to reload. If we set SUAVE provider, we want to reload. If we set connected account, we want to reload. React will actually suggest other stuff too that it thinks you need. So we'll set that. And now, yeah, it's infinitely looping. So, okay. Let's stop that for a second. Oh boy. Hold on. I gotta stop this. We did something wrong. We can leave all this stuff, but we just need to conditionally trigger load. So if the ultimate goal for this load function is to load, I mean, aside from initializing the stuff that we need to use, I think this function is considered done when we fetch the number from onChain. So we can just say, like, if the number is undefined, and we need a strict check for that because 0 could be a number, but is also falsy. So say if our number is undefined, then load. Oh no, that's still need to set the number. Oh yeah, but we still, oh my god, we still haven't set the number yet. Okay, so run it once. And then in get number, let's set the number. So this res, we're logging res and we see it's got a data field. So we need to make sure that we're picking that up, res.data. And make sure res.data exists. Okay, I think that should work. No. Why is it doing that? Oh. No. Oh yeah, okay. So the condition is that the number is defined, but the way we're calling it, I stopped the infinite loop. The way we're calling it, when we get the number back, we're calling parse int, and %will be 0. Why doesn't that work? I don't know. Let's see. Maybe just ignore SUAPP provider here. I'm gonna brain fart, doing something wrong. Oh, set SUAPP provider is always called. Yeah. Yeah, I think that works. This doesn't need to be there. There. There we go. I think that's it. Yeah. Just needed to prevent, yeah, infinite loops. A little bit tricky, but there we go. It's good. So now when it loads, it's going to look for Ethereum. It's going to make sure we have a SUAVE provider, and if not, it's going to make one. This'll loop through and fix its own conditions until everything is good. And then, as we go through, it will render more and more of what's available. So now we can see here, number 0, we're getting that from on-chain. So it's pretty good so far. Now we want to actually change the number. What is this? Move it inside the use effect callback. Yeah, okay. I don't like these lines, so fine. Alright, that looks good. So yeah, let's get to sending it. So we need a transaction request SUAVE. That's what this thing was for. And make a function for that. Send CCR. Alright, make sure the wallet exists. And it's already, okay, it's starting us off pretty well. Counter address is correct. We're gonna, set function data in the data field. So this is how we're gonna call the function. So we'll call set number here. So set number. And again, we can we can omit the args parameter because we're not sending arguments here. We only need, the function name in the data, and that should be enough. Everything else goes into confidential inputs. So yeah, this is where we specify here what is going to be read here. Right? So confidential inputs, we just need to ABI encode this uint256 style of integer. So you can use this VM helper function, encode ABI parameters. And it takes 2 arguments. The first one is a list of types, type definitions. You can, like, you can see Copilot is suggesting that we use the name of value. You can use the name of the argument. You don't need to. I'm just going to use types. And this is just like a string representation of the type name. So here we have 1 argument. It's a uint256. And then we'll actually pass the argument. And the argument, yeah, it's TBD. Because we have not set up the input to change the number we actually want to send. So yeah, let's just do that real quick. Down here, we need an input. It's a number type, change, set the number. Yeah, looks pretty good. Heat at target.value. Yeah, so it's taking this string, parsing it into an integer. And set the number. Oh, this is actually not quite right. Set the number is our little hook thing. We need to set it in the UI. If we want, what we want is a send CCR function. It doesn't take any arguments because it's going to take everything from the state list that we're using. Yeah, we need to pass whatever this is, whatever the input is giving us. So, okay, send CCR is an argument. Input num. Well, we're always going to be getting a string in this case, and send CCR is like an app-specific function, so I don't feel like I need to go down to like big int or number. I can just assume that it's always a string, and I'll just decode it. At least a hex string. Into a big int, so that it's easy down there. Yeah. Okay, so we got our confidential input. We need the kettle address in CCR. This is basically it's like an account in SUAVE that is responsible for sending this. It actually sends the callback. So like when you call this set number function from CCR, so you're calling this function and returning this, and then the kettle, or the kettle account, is going to take this call data, and it is actually calling this onset number function. Anyways, for our purposes, we just need to know the address of it. So once again, I've got my handy dandy PR here. I'll take the kettle address and I'll pop it in over here. This is probably something we could also to the library. This address is specific to the DevNet. If you're doing this on like the live, I'll send you audio like that. Oh, is that better? Yeah, I see the white noise you were talking about on the visualizer. Sorry about that. Ping in chat if it keeps happening. Yeah, okay. So kettle addresses. If you're on like testnet, this address will be different. Yeah, just keep in mind, you know, keep your kettle addresses close. Okay, so the last params we need are gas and gas price, standard stuff. I'm just gonna estimate, like for this one, no more than 100,000 most likely. So I'll just try that. The reason I'm just setting these manually, I haven't been able to get the estimate gas to work implicitly. But you can do you can get the gas price from your SUAPP provider. Get gas price. You can use that, but for the actual amount of gas used, I've had some trouble getting it to work in SUAVE VM. So for now, what I've been doing is just setting this high, and then you can run it and check the transaction receipt, and that'll give you how much was actually used, and then you can adjust from there. But okay, so that looks like everything. Data, confidential inputs, kettle address, gas. We could do type as well, but it's optional. It should be, if you specify confidential inputs or kettle address, then this type will automatically be filled in for you. But we could just specify it anyways, just to be verbose. But okay, so this transaction request is ready to go. We just need to sign it and send it. So we can just go wallet.send transaction tx, and we'll get a tx hash back from that. So yeah, we'll grab that. We'll just log it for now. And then all we got to do is link it here. So nccr e.target.value. Oh, and yeah, this actually. Well, let me just make sure that I'm not doing this incorrectly. This value it's a string, but it's a decimal string. So this is expecting a hex string. I don't know. How about that? That's kind of goofy. This is another thing. But that'll work. Parsing an integer to string base 16. And string is not assignable to parameter type. Okay, so we just need to make sure we're explicitly declaring that's a hex, and that should work. Okay. Right, and then we were going to, well, we need to set, oh yeah, that's, oh, whoops. So I'm, this is the input. I was thinking about the button. this is what we want to put in the button. My mistake. This needs to update the number. Or no, we need a new one. Input num. Yeah, there we go. So make sure I don't get confused again. Number from on-chain. Use input number. Okay. String. So input anonymous function to call this with an argument of our choosing. And this is, oh no, this is one of those e.target .value. So whenever we're typing, every key press is going to trigger this set input num. And then we need a button. Yeah. That's what we were looking for. And then we just got to do this thing again. And this is not that anymore. This is input num. String undefined. We got to make sure input num exists in this context. So make sure input num here. So I just wrap this in some curly brackets, and then that allows me to put JavaScript sort of intermixed with the HTML here, or JSX, or whatever it is. So this is just asserting that if input num exists, then we'll render all this stuff. But if not, then we'll just do nothing, and you won't see the button. So, okay. We should be able to check that out now. Input num is undefined, so no button. Nice. And it's broken. Okay. Need to take like a 2-minute break. But yeah, I'll be right back. Okay. So we got an error. Cannot convert 1E0F3 to a big int. We probably parsed the string incorrectly somehow. CCR. Input num. Big int. Well, what's input num? Or rather, what's... well, yeah, what's input num? Let's expand this. Get the brackets right. Okay, on click. Okay, input num. Type of input num. Yeah, it's decimal string. Well, see, that makes sense. Oh, I know. It just needs a 0x in front of it. Yeah. Okay, that's good. So now we got a new error. ETH sign has been disabled. You must enable it in the advanced settings. So, yeah, this is a good time to explain the sort of structure of CCRs, confidential requests. So, the confidential request type, the structure of the thing, it's basically got an inner type and everything else that's in the wrapper. And the input type is what we sign over. And crucially, we don't sign over confidential inputs, because if we did, then you would have to reveal confidential inputs to verify the signature. So instead, we sign over confidential inputs hash. We put that in the inner object. That's what we sign over. And then the whole thing is, sent like a normal transaction. But yeah, what I'm getting at is the structure of the transaction itself is not compatible with like normal wallets. That's why we have SUAVE VM to handle that custom encoding and signing of the transaction request, or the CCR. So to make this work for MetaMask, what we had to do with the way we have it now, we have to use ETH sign, and we just have to give it that inner object to sign directly, rather than using those convenient, send raw transaction or sign transaction or whatever. But yeah, because of that, we need to enable ETH sign danger mode in MetaMask with the EIP 712 PR in SUAVE Geth. That all goes away, which is super nice. Essentially, what we did there is we just replaced the inner object with an EIP 712 message, and because it's an EIP 712 message, it plays really nice with MetaMask. So when you want to sign an EIP 712 message, MetaMask will give you that whole like JSON outline of what you're actually signing, rather than just some opaque hash. And you don't need to specify the RPC endpoint. So one thing I haven't done yet here that I need to do is I need to add SUAVE-Geth, my SUAVE-Geth devnet to my to my MetaMask networks. So I'm sending the request to the right place. So just do that real quick. SUAVE localhost. The chain ID for SUAVE-Geth. We need. It's hard to remember. It's like 161 3185 or something, but yeah, I can't remember exactly. But it's in the docs. Let me look it up. Rigid testnet. Chain ID. There we go. Is that right? 168.131.25. Ah, that was close. Okay. Where did we need that? Here. Chain ID is that. Currency symbol. Oh, let's use ref. And we can add the block explorer too. Rigil has, well, actually no, let's not, because this is localhost, not Rigil testnet. So we'll leave that. All right. Got it. Oh my god. Okay. So we got our account. We're connected to SUAVE localhost. We still need to send ourselves some SUAVE ETH or some Rigil ETH. And we can just do that from cast. We have our private key here with 10 billion. We can just do a cast send. And this will be on 8545. That is like an anvil key, and it needs to be this one. Oh boy. Yeah, 91AB. And then our address that we're sending it to is here in MetaMask. That one. Alright, so we'll send ourselves 1 Ether. There we go. Let's check MetaMask. Ah, works great. Okay. So we got that. We're connected. Okay, so everything should be set. Now we just need to enable ETH sign. So that's in settings. I think advanced. Yeah, ETH sign requests. I only sign what I understand. Yeah. And yeah, we don't like really want to use this ETH sign. It sucks, but it's what we got for now. It's going away pretty soon, but just not 100% there yet. So, okay, I'm gonna refresh this. Clean slate, no error messages. Let's try and set the number. All right, we got a sign request. Sign it. And all right, we got an error. RLP input string too long for bool. Decoding into compute request. Oh. Oh, whoops. Okay. So, yeah, underlying error with this new SUAVE Geth release. It's not compatible with the original transaction wrapper. So I think we're gonna have to either switch to EIP 712 right now, or downgrade SUAVE Geth. I just want to get this working, just see it. So I'm gonna downgrade SUAVE Geth. All right, let's just go to this previous commit. All right. Rebuild. Okay. Oops. Okay. So downgraded SUAVE geth. Now we've got to create the we got to deploy the smart contract again, and then we got to send ourselves some more ether because we just reset the SUAVE geth state. So just got to redo this stuff. This is a different address here, and then cast send, give ourselves another ETH. All right, now we should be back on track. If we run this again, it hasn't detected our new address. We might need to restart the app. Oh wait, no, that's the account. Whoops, I'm reading that wrong. I want to show the address here too. Oh. Okay. So yeah, that looks good. That's the right address. Now, new number. Nice. Transaction hash. Okay, that's good. This succeeded. So let me look at the SUAVE geth logs. Oh. Docker logs -f to follow. And yeah, submitted transaction. Everything looks good. This error is normal. You can ignore that. But yeah, it looks like it's working. So if I refresh, yeah, we've got 1, 2, 3. Sweet. So yeah, there's like a couple more things we could do to make the UI a little better. You know, we could, whenever we hit the button, we could wait for the transaction receipt. So like here, we want to see if the transaction was actually successful because we landed it on chain successfully, or we got it to the RPC correctly, but we didn't actually, you know, we don't know if it reverted or not. So that's the next thing I want to check. We could do that by getting the receipt. So swap provider.get transaction receipt. This takes a hash inside an object like that. So get transaction receipt given the transaction hash, and if we can check receipt. Well, receipt's not going to be undefined, so we just need to check the status. So the receipt status is either going to be, well, in the raw form it's 1 or 0, but in SUAVE VM it's reverted or successive as a string. So let's say if it's reverted, let's just throw an error. Actually no, I like the affirmative. Success. If we're successful, if we're successful, maybe we should actually just do a little. I'd like to update the number, but I have to break this get number thing out. It doesn't seem like a good use of time. Let's just say, let's make it just a status string. We can render it down here, like right here. conditionally render it. And then status. Yeah, so we'll just set status with the actual receipt status. And then we don't have to do that check here. So then, yeah, 3, 2, 1. Send a new one. Oh, error. Oh, whoops. Nonce too low. Yeah. So that was another. That's another thing that I need to figure out in SUAVE VM, but MetaMask for some reason is not getting the nonce properly from from SUAVE. So when we send it, we just need to get the nonce ourselves. Get transaction count from SUAVE provider. Pass it the wallet address. It'd be wallet.account.address. And wrap this up in like, what is the yeah, just address. Get transaction count of address at wallet.account.address. And then, yeah, we'll just pass the nonce here. This is already the right type, so we're good to go. Transaction successful. Sweet. Yeah, I think I maybe put it inside strong. Yeah. Cool. Okay, so that's like that's a successful SUAPP. That's just like the basic, rudimentary, bare bones, as simple as it can possibly get. SUAPP. Let's see how much time we got left. We got an hour. Thanks, Ryan. Yes, very confusing indeed, but you get used to it. I think, especially, you know, this set number, onset number, callback sort of paradigm. It's very, you know, unusual. It's like, yeah, not something that I would expect, you know, Solidity developers, Ethereum developers to like be familiar with, but yeah, that's how it works. Real quick, I guess we could try out the EIP 712 thing. I can't guarantee it's gonna work, but we can see what the state of it is. The actual migration is pretty simple. So let's see if we could do it. Alright, we need to upgrade SUAVE again. Yep. Shut down the old DevNet. Spin up the new DevNet. Rebuild. And, oh yeah, we also need to update the SUAVE VM. I need to get the right branch here. This is a change that hasn't been merged yet. So I will need to explicitly check out this branch here. Let me get that commit hash. Can I use that? I don't remember exactly if I can do this from GitHub. It might be easier to just build this locally and yeah, just link it from my local build. Oh, okay. So, okay, Docker Compose is running again. Just before I forget, I'm going to create, whoops, the contract again. Same address because it only depends on the nonce of the account that sends it. So we can leave that and then send myself some ether again for testing. Okay. And then in our TS swap, well, actually, before I screw this whole thing up, I'll commit these changes so that we have, so everyone can use it in its working state. Yep. All right, now we can screw it up. So I'm just gonna, I'm paranoid about how Bun updates dependencies, whether it caches them. I don't know exactly how it works. So I'm just gonna be erring on the side of caution, and I'm just gonna remove SUAVE VM directly. Wait. SUAVE. Oh, we're in the wrong directory here. If it gets. Okay, so remove that, and then we need a new terminal. SUAVE VM. Make sure I'm up to date. Check out that 712 branch. Nah. I just want the branch name. 712 CCR. Yeah. All right, then here I need to run build. It's going to compile all of my TypeScript into a library that I can use. Make sure it worked. Yeah. So these are the like outputs of the build. Types, ESM, and CJS, and those are like different ways of importing JavaScript. But okay, it worked. So we've got that built, and now we can run bun link. Whoops, we gotta go to source for that. So bun link here, and then that will link on my computer this Flashbots SUAVE VM to this local build. So then to import it, I can just run that. So then in my SUAPP, where I've just uninstalled the official version, I can run bun link Flashbots SUAVE VM. Now we should have the EIP 712 compatible version. And I believe I don't need to change anything here because the way this is set up, this method sends transactions. Where is it? Yeah, wallet.send transaction. Well, in this case, I don't want to find it. But yeah, it does the EIP 712 signature instead of ETHSign. So I think we should be able to just current directory done. This will just work straight away. How is this? Oh, it's already running here. All right. All right, number 0 again, set to 1, 2, 3. Nice. Yeah, it totally worked. So yeah, this is what the EIP 712 version looks like. It's all the same. You can see we're signing over confidential inputs hash, like I was talking about before. You've got all your transaction values. But yeah, it's not that scary ETHSign dialog. It's this nice looking EIP 712 thing. And hell yeah, it works. So yeah, that's I don't know how much I can say yet, but that's probably what we're going to be doing in SUAVE, is this EIP 712 style. So get excited for that. But yeah, I think that's all I have. Let's run back through this checklist and see if we could check everything off. So made countersol into a SUAPP. Oh, we didn't write a forge test. Okay, let me write a forge test real fast to show you what that looks like, because that's important. It's super helpful. So back here, counter.t.sol, we commented all this stuff out. If you want to write forge tests that use SUAVE precompiles, you can go, see if I remember it. I want to look at the source code again. So SUAVE std, source, and test. Yeah. So that's what we want. We want import SUAVE enabled from SUAVE std test. Yeah. This the plugin's wrong again. This is fine. But yeah, if you want to test precompiles, so say make a counter. What does that do? Ooh, that'll work. Oh, setup. We gotta get rid of setup. That's not. We do that. All right, yeah, so it's in the fallback. This is happening because, I believe because, we didn't set, this might be too deep. This is like I could go like a whole hour explaining this. How to call confidential compute requests in a test. There's like a few steps to do, but like I'll just do the basic version here, so you're just aware of forge tests and how you can use them with SUAVE. So if you use this SUAVE enabled component, well, let's also get SUAVE in here. SUAVE from SUAVElib, yeah. So with this, you can test precompiles directly. So if we had something like SUAVE dot HTTP request. I need to build an HTTP request. Memory equals. Interesting. I don't know if it needs that. I don't know, let's try that. I don't know if that's even valid code. Expected 5. What's in the HTTP request? String URL, string method. All right, so we got URL, we got method, headers. Oh, it's just 0, so that's fine. Body. It could probably autocast. And with Flashbot signature bool. False. For this one. What is it supposed to be? String headers. Oh. Your string. All right. Okay. So yeah, this worked, sort of. So we got this error, precompile reverted, domain api.coingecko.com is not allowed. So this is happening because SUAVE execution geth. Well, no, sorry, it is SUAVE geth. SUAVE geth, it has a whitelist that you have to specify. So I have this little script here that I just use to hold on to my, initialization, just a script to run it for when I'm developing, because I change these every once in a while. But if you pass this this argument here, suave.eth.external whitelist, you can add in domains here that aren't included by default, because by default it's like super locked down. So if you wanted to do this, let's just go all the way. We're going to shut down this devnet that we have, and then we're going to run this local devnet here with my custom parameters, just by running that script. And so that I've set the external whitelist equal to the wildcard, so anything. When I do that, now because I'm running this SUAVE geth locally, I've also got to go and run SUAVE execution geth. And I've got another one of these same scripts here. It's a little bit older with old params, but it works. This is just gonna basically do the same thing that I was doing with the Docker Compose devnet, but I'm just running these directly on my machine now. So yeah, now we just need to I need to deploy the contracts again and give myself some ETH again. Here, so forge create, same address again, that's good. Cast send, got my ether. All right, now our chain is set up again to test with this app. And oh shoot, man, I missed one more thing. I forgot to make. Oh, I did. Okay. Yeah, it's built. Okay. Sorry, one more time. All right, it's initialized. Okay, so yeah, we're running SUAVE geth with now a wildcard for the whitelist. So if we run our forge test, that's calling CoinGecko, domain not allowed. What did I do wrong? Yeah, there might be a new change that I haven't looked at yet. Um, so sorry for the bummer conclusion. Um, but yeah, if you're looking to write, if you're looking to test your precompiles or your functions that use precompiles, this is the way you would do it. Obviously, you got to figure out this little error, but yeah, forge tests are really helpful for. Um, they're not really super helpful for testing full integrations, although we have done it. Um, but yeah, it can be kind of difficult. But if you want to test, like little snippets to make sure that you're calling the precompile right and you're getting the right data back, these forge tests are super helpful. You can also do, like console logs here if you have console or console2, and console2 just has more helper methods for different types or whatever. But you can do console logs to get your like to print values from your precompiles, what they return, stuff like that. So yeah, definitely make use of forge tests when you're developing swaps. Okay, that's all that I have for today. Yeah, once again, going back to the little checklist. We failed here, but we did that. Sent the CCR with MetaMask. Did all the shit the MetaMask wants, and we even got to EIP 712. This is a note for myself to disable it for my own personal MetaMask use, but yeah, that's for you. So okay, I think that's all I got. Thanks everyone for tuning in. Appreciate y'all hanging out, and yeah, we'll catch you in the next one. The next one is going to be more advanced. We're going to be getting deeper into a really complicated kind of swap that uses lots of different precompiles. We have heavy usage of this HTTP request specifically. So we can do things like talk to ChatGPT and make swaps that rely on API values from Web 2 APIs, and you can take Web 2 things and improve them in a Web 3 way. So it should be pretty exciting. Yeah, we'll get to that in the next one. I'll release the outline the same as this one before I announce it. So you'll have all that ready to go when we start that one. So that's all for now, and see you at the next